Look up at the night sky tonight. Looks pretty peaceful, right? Almost like a perfectly balanced clockwork that's just gonna run forever. But honestly, that safety is kind of an illusion. Today we're diving into a genuinely terrifying question. Could humanity survive on a rogue planet? We tend to think of our solar system as this permanently safe harbor. But what if I told you the very ground beneath your feet could be violently evicted into the eternal, freezing dark of interstellar space? No way, right? Well,
Okay, let's dive right into this. Is Earth permanently safe in its orbit? We've had a really good run, about 4.5 billion years of a comfortable, stable balance. But the wider Milky Way? It's an unbelievably chaotic place. Gravitational encounters happen. A close encounter with a massive passing star could literally overpower our sun's gravity. It wouldn't necessarily crush us on impact, but it could hand planet Earth the ultimate eviction notice, tearing us right away from the only warmth we've ever known.
Section 1. Wanderers in the Dark. The Lonely Worlds Between Stars.
so to understand how this happens, we have to look at the vast, empty spaces between star systems. We usually picture space as just stars with their loyal little planetary families circling them, but there is this massive hidden population out there right now: rogue planets. Basically, a rogue planet is a planet-mass object that travels through space entirely alone, without orbiting any star at all. These are frozen, pitch-black deserts. You see, a lot of them got violently thrown out of their own solar systems during the chaotic, growing pains of planetary formation, like when gas giants were battling it out for gravitational dominance. And get this, astronomers estimate there are probably billions, maybe even trillions, of these lonely worlds just wandering through the Milky Way alone right now. It's wild. Section 2. Evicting planet Earth. How a star could steal our sun.
All right, so how does a planet like ours actually get evicted? Picture this. A dense red dwarf star comes wandering into our inner solar system. Gravity is basically a gigantic cosmic tug of war. So if a massive interloper gets too close to Earth, it completely overwhelms our sun's gravitational hold. It steals us away, bends our trajectory, and flings us out into the galactic void at just unbelievable speeds. And I want to anchor this in the hard data for a second, because we aren't just making up sci-fi doomsday fiction here. Astrophysicists have calculated the exact odds of Earth being gravitationally ejected from the solar system in the next 5 billion years, and it sits at exactly 1 in 100,000. Now, sure, that's a really small probability, but in cosmic terms, it's not absurdly impossible. 1 in 100,000 means it is absolutely a very real physical possibility.
Moving on to Section 3. The Big Freeze. A chronological descent into the dark.
Okay, let's say those 1 in 100,000 odds actually catch up to us. What happens next? Well, our sun would slowly start shrinking in the sky, and Earth's final winter would set in. Even the eerie red glow of that passing star would eventually fade to black. It's this gradual, unstoppable descent into the dark. And the temperature drop? Completely catastrophic. By the time our rapidly expanding orbit crosses where Mars is right now, global surface temperatures drop to -50 degrees Celsius. Our beautiful blue-green world turns the pale gray-white of death. By the time we hit Jupiter's distance, we reach a totally lethal -150 degrees. And as we pass Pluto's orbit, drifting out into true interstellar space, we bottom out near -270 degrees Celsius. That is barely above absolute zero.
And this crazy temperature plunge triggers a really bizarre multi-stage collapse of our entire environment. Step 1, the oceans freeze all the way through. We're talking ice as hard as solid bedrock. Then, it gets so unbelievably cold that the atmosphere itself literally starts freezing out of the sky. Nitrogen snow falls to the ground. Then, oxygen snow. Think about that for a second. Eventually, the very air we breathe turns into a 10-meter-thick icy sheet wrapping the entire globe, just trapping all the frozen corpses of surface flora and fauna deep beneath it.
Section 4. Life Under the Ice. Biology in the Pitch Black.
Now, what's really interesting about this slide is that the frozen, silent tomb up on the surface isn't necessarily the end of the story. To find a glimmer of hope, we have to pivot away from the dead surface and look miles underground to the geothermal warmth of subglacial oceans. Let's look at the actual energy math here. Right now, a massive 99.97% of Earth's total energy budget comes straight from the sun. Take the sun away, and surface life is literally impossible. But to survive on a rogue planet, life just has to rely entirely on that remaining tiny sliver, that 0.03% of our energy, which radiates outward from Earth's incredibly hot inner core.
So check out the extreme contrast between these two environments. Up top, surface conditions are completely dead.
lifeless, and plummeting to negative 270 degrees. But miles below the ice, it is a totally different ballgame. Earth's inner core is basically a giant metal ball that's as hot as the surface of the sun itself. This heat drives liquid oceans, pumping energy into hydrothermal vents and black smokers on the ocean floor. And just like we see today, these vents could easily sustain vibrant alien-like ecosystems of extremophiles, bacteria, and giant tube worms. They'd be completely cut off from the frozen universe above, just thriving down there in the pitch black for billions of years.
Which brings us to Section 5, Humanity's Frozen Future, Making a Stand in the Void.
So where do we fit into this? How exactly would humanity prepare and survive? Well, the one silver lining here is that space is vast, and things move predictably. We wouldn't be blindsided by this. Astronomers would spot this rogue star approaching thousands of years in advance. We obviously couldn't stop the star, but we'd have immense time to orchestrate a massive technological pivot. Living on the surface is obviously a no-go, so a few million humans would have to migrate down into artificial subterranean complexes built kilometers deep beneath the ice. The essential survival checklist? We'd have to perfectly harness geothermal energy from the crust, drastically scale up nuclear energy, and ideally master fusion power using the basically infinite supply of surrounding water ice as fuel. It would be a cramped artificial existence for sure, but theoretically, humanity could survive for hundreds of thousands of years like this.
And this subterranean existence leads to a surprisingly optimistic fact. Let's say hundreds of generations go by in these underground bunkers, and humanity decides, you know what, we want to leave this frozen rock and find a new, warm star. Because our entire atmosphere froze solid and collapsed onto the surface, escaping the planet actually becomes significantly easier. There's no air resistance, no atmospheric drag to fight against. Our icy tomb basically makes spaceflight incredibly efficient.
Which leaves us with this truly fascinating, kinda haunting final thought. Imagine those distant descendants, millions of years from now, finally living on a new world orbiting a new sun. They might sit around and tell legends about Earth's ancient past, stories of our lost home, of a mysterious icy planet floating alone and empty through the dark of space. It really makes you wonder, doesn't it, as we look out into the Milky Way tonight, how many frozen rogue worlds are drifting past us right now, quietly carrying the lost secrets of civilizations that once lived in the light.